So the next topic in the context of Spring and Spring Boot is to look at some of the design patterns that it implements. Hopefully you took the CS 3251 course here, and so you have at least some mild grounding in patterns. Patterns are basically reusable solutions to problems that arise when you build software. And they apply to many different domains. If you took the Gang of Four, if you took the CS 3251 course here, you probably are familiar with some of the so-called Gang of Four patterns like factory method and bridge and iterator and chain of responsibility or strategy and so on. And we're going to look at some other patterns that Spring Boot implements. Now, not surprisingly, Spring Boot implements a whole bunch of design patterns, including a bunch of the Gang of Four patterns and many other things besides. But we're going to focus primarily on the patterns that it implements that have to do with the programming style that it exposes to application developers. So the particular pattern we're going to focus on here is the so-called convention over configuration software pattern. And this is the icon that shows convention over configuration. Very clever. And you can read more about convention over configuration here at this Wikipedia link. So what's the overall big theme of convention over configuration? The goal is to make it possible to create web apps by refining a general reusable blueprint. And this is sometimes talked about as opinionated ways of doing things. In other words, the framework, the approach, the platform, if you will, has certain goals and certain design intents that are put there because people believe that's the best way to do things or the most effective way to do things. It's opinionated. And the idea of a blueprint, of course, is that you can use that as a starting point to make your applications. So a lot of stuff kind of comes along for the ride, and you don't have to think too hard about things that are easily done in a relatively automated and common way. In particular, software frameworks and applications use this pattern to reduce the number of decisions that we have to make as developers without sacrificing flexibility. So you think about this in terms of two different points on a spectrum. One thing to do would be to give people just a bunch of building blocks and say, do whatever the heck you want. Think about a big box full of Lego pieces with no map or no instructions on how to put them together. At the other end of the spectrum is something that's very rigid. It's like everything must fit into this Procrustean bed of solution space with no deviation at all. That would be too inflexible. So the idea here is to give people this blueprint that gets you most of the way there, but when necessary, you can customize and tweak things in order to be able to meet your other requirements or the environment conditions in which you find yourself running. And a lot of those things typically have to do with stuff like reliability or scalability or reusability or portability. So here's some of the things that convention over configuration has as these themes. So one is provide reusable and reasonable defaults. So make it easy to do stuff that works out of the box because you get what's called the principle of least surprise. Things work the way you expect them to do. So for example, if there's a class called sales in the overall data model, then there should be a table in the database that's called sales by default. So make things that map consistently and without surprising people. So that's the concept of reasonable defaults. And we'll see there's lots and lots and lots of reasonable defaults that are built into Spring. However, you want to make it possible to deviate without having to write a lot of extra stuff. So you want to be able to deviate in very consistent and stylized ways. So for example, if you really don't want to call your table sales, but want to call it product sales, it should be possible to do that without having to do a lot of extra work. So the idea here is only have to specify or program or configure or whatnot the unconventional things, the things that aren't the defaults. The way I like to say this is you want to make software where it's easy to do things using defaults, but if you don't want the defaults, it's not impossible to make a change, and it doesn't require rewriting everything from scratch. So that's another key theme. And you'll see that play out in a lot of ways when we start looking at the details of how this works. Another theme is eliminate distractions. So what does that mean? So one example is you who is a user of this framework, the Spring framework, should not have to need to worry about low-level network programming details. You shouldn't have to worry about marshaling and setting up connections and allocating memory and passing messages back and forth and going from one format, a Java format, into something that can go across a network in a portable way, and then reconstituting the Java calls back on the server side in order to be able to do operations on methods, on controllers and services and so on. All that stuff should be done for you. And moreover, you'd also like to be able to leverage declarative configuration mechanisms. So when you do need to make changes, you'd like to be able to do that without having to write a lot of code, but more like changing settings through well-defined hook methods and other factories. So that the idea is to hide a lot of the how and only focus on the what you want to do. Another thing that eliminates distractions is have the infrastructure, the framework, manage the event loop or event loops via inversion of control. So again, we want this to be something that's hidden from you. You shouldn't have to worry about how the requests come into the system and all the low-level checking and processing and demultiplexing and dispatching that takes place. You just want to write good old Java objects and let the framework do all the busy work for you. And another theme is reduce the number of decisions you have to make. You should be able to do things in a way where it works out of the box. You can make changes, but they're all done as much as possible through various configuration means as opposed to programming them imperatively. You want to be able to configure them declaratively. And a simple example of this would be the auto-wiring of fields to their implementations, which can be done and is often done and probably should almost always be done using auto-wiring. And we'll talk again more about auto-wiring later. So these are some of the key elements of the configuration over convention pattern that is at the heart of Spring. Again, there's boatloads of other patterns that Spring implements, and we will talk about some of them as we go through this. A good example would be the proxy pattern. So when you make method calls in Spring, there's proxies that abstract away from all the low-level details so you don't have to think about networking. And there's also things, for example, we'll talk about having to do with how you can communicate types from Java, like lists and maps, across a network connection. That's all handled for you. They're patterns that work in that. Things like factory method and proxy again. There's also other patterns that are used for dealing with concurrent programming. And again, there's pooling patterns and resource management patterns and so on and so forth. So lots and lots and lots and lots of patterns. This just kind of scratched the surface of some of the patterns that are in Spring Boot.